We have found that the derivative with respect to x of e to the x is itself, is e to the x. And this is a really special derivative. This is saying that at any point on the function e to the x, the value of the function is equal to the value of the slope of the function at that point. In other words, the value of the function is equal to the instantaneous rate of change of the function at any moment in time. So the derivative of e to the x is the function itself, e to the x, and if for any input value x, the slope of y equals e to the x is the output value e to the x. Let's just look at this for a few points. So we already observed that if we drew the tangent line to the curve y equals e to the x at the point x equals 0, so this is x equals 0, then the output of this function, e to the 0, is 1, and we see that that's also the slope of this curve, so that's equal to slope of tangent line to e to the x at x equals 0. So there that is for that value, but it's true for any input value that we put in. So for example, if we put in x equals 1, so here's the output, and the output is e, which is 2.718 ... If we look at the slope of that tangent line to the curve, we were able to draw that slope perfectly and find it perfectly, that slope of the tangent at that point, at the point x equals 1, would also be e to the 1, which is 2.718 ... That would be the slope of that line. And just one more, if we looked at the point x equals -1, then if we look at the slope of this curve, the slope of y equals e to the x at that point, the slope of this at x equals -1 is e to the -1. That's 1 over e, which is approximately 0.3679. It's also irrational. And so that is, again, the slope at -1 is equal to the output of the function at x equals -1. And functions of the form f of x equals c, a constant, times e to the x are the only non-zero functions with this property. So obviously the derivative of 0 is 0, so that those functions also have that same property, but these are the only basically interesting functions that have this property. So for example, if f of x is 12e to the x, then f prime of x is, well, we know by the constant multiple rule that the derivative is the constant times the derivative with respect to x of the function e to the x. And so that's 12 times derivative of e to the x is e to the x. We're going to talk a little bit about the function y equals natural log of x. So y equals natural log of x is the inverse of the function e to the x. So here we have graphed y equals e to the x in red and y equals natural log of x in blue, and we see that those are inverse functions. One way to see that those are inverse functions is that if you reflect across the line y equals x, like put a little mirror right at the line y equals x, then these functions reflect off of one another. So for example, here's the point 0, 1 on e to the x, and here's the point 1, 0 on natural log of x. They reflect the x and the y values. Here is the point 1, 2.718, 1 and e on the red function, on the function y equals e to the x. And here is the point e, 1 on natural log of x. So we actually don't yet have the tools to prove the derivative of natural log of x, but I'm simply going to state it for now, and later in the course when we talk about derivatives of inverse functions, we will prove the fact that the derivative with respect to x of natural log of x is equal to 1 over x. So the derivative of natural log of x is 1 over x, and I am going to state that without proof for now, and we will do examples. I'll expect you to learn that formula, and later on in the course we will prove that that is true. If we look at, say, x equals 3 and look at the slope of the function at that point, could that slope theoretically be 1/3? Yeah, that makes sense. This is very casual. If we look at, say, 1/2 and look at the slope of the function there, could that theoretically be the reciprocal of 1/2, a slope of 2? Yes, that seems reasonable. Okay, that's as much justification as I'm going to give for now, but later in the class, we will prove this theorem. The derivative of natural log of x is equal to 1/2. Let's just do one quick example. Let's say f of x is 3e to the x minus 2 natural log of x, and let's find f prime of x. That would be equal to derivative of 3e to the x by the constant multiple rule. That's 3 times the derivative of e to the x, so it's just itself, minus 2 times the derivative of natural log of x is 1 over x. And so we could write that as 3e to the x minus 2 over x.